Module 6. Ions, ionic compounds, covalent compounds, and ionic bonds. Ions, ionic compounds, and ionic bonds are critical concepts in the study of chemistry. In this chapter, we will explore writing equations and formulas that represent chemical compounds and reactions, balancing chemical equations, the roles of various ions in compounds, and polarity in compound molecules. Ions. An ion is an atom or molecule that has gained or lost one or more electrons, giving it a net positive or negative charge. Ions can be classified as cations or anions. Cations are positively charged ions that are formed when an atom loses one or more electrons. Anions are negatively charged ions that are formed when an atom gains one or more electrons. Ionic compounds. An ionic compound is a chemical compound composed of positively charged ions or cations and negatively charged ions or anions that are held together by strong electrostatic interactions. These compounds are formed when one or more electrons are transferred from a metal to a nonmetal, resulting in the formation of cations and anions that are attracted to each other due to their opposite charges. Covalent compounds. A covalent compound is a chemical compound composed of two or more nonmetal atoms that are held together by the sharing of electrons. In a covalent bond, atoms share electrons in order to achieve a more stable electron configuration. This sharing of electrons results in the formation of a molecule, which can be composed of two or more atoms of the same or different elements. Ionic bonds. Ionic compounds are formed through a process known as ionic bonding. Ionic bonding occurs between atoms of different elements that have a large difference in electronegativity, or the ability of an atom to attract electrons towards itself. In ionic bonding, one atom, typically a metal, loses one or more electrons to become a positively charged ion or cation, while another atom, typically a nonmetal, gains one or more electrons to become a negatively charged ion or anion. The positively charged cations and negatively charged anions then attract each other due to their opposite charges, forming an ionic compound. For example, when a sodium atom becomes an ion, causing it to become sodium chloride, NaCl, it loses one electron to become a sodium plus cation, while a chlorine atom gains one electron to become a chlorine anion. The resulting attraction between the sodium positive and chlorine negative ions forms the ionic compound NaCl, or sodium chloride. Equations and formulas for chemical compounds and reactions. Chemical equations and formulas are used to represent chemical compounds and reactions. The formula of a compound represents the atoms or ions in the compound and their ratio. For example, sodium chloride or table salt has the formula NaCl, which represents one sodium ion, sodium positive, and one chloride ion, chlorine negative. Chemical equations represent the reactants and products of a chemical reaction and are balanced to show the conservation of mass. Balancing chemical equations. Balancing chemical equations involves ensuring that the number of atoms of each element in the reactants is equal to the number of atoms of each element in the products. This is done by adjusting the coefficients in the equation. The coefficients represent the number of molecules of each substance, while the subscripts represent the number of atoms in each molecule. Roles of various ions in compounds. Ions play different roles in chemical compounds. Cations typically act as Lewis acids, which are electron acceptors, while anions act as Lewis bases, which are electron donors. In addition, certain ions have specific roles in biochemical processes, such as the role of calcium ions in muscle contraction. For example, table salt, NaCl, dissolves in water more effectively than sugar because NaCl is an ionic compound, meaning it consists of positive and negative ions that are held together by strong ionic bonds. When NaCl is added to water, the polar water molecules surround and separate the ions, breaking the ionic bonds and allowing the ions to disperse evenly throughout the water. In contrast, sugar is a covalent compound, consisting of molecules held together by relatively weak intermolecular forces. These forces are not strong enough to be broken by the polar water molecules, so sugar does not dissolve as easily in water as NaCl does. Polarity in compound molecules. Polarity in compound molecules is determined by the distribution of electrons in the molecule. A molecule is polar if it has a dipole moment, which means that the electrons are not evenly distributed. Polar molecules have a positive and negative end, while nonpolar molecules have an even distribution of electrons. For example, when KCl or potassium chloride dissolves in water, the ions in the compound are attracted to the polar water molecules due to their opposite charges. The positively charged potassium ions, K positive, are attracted to the negatively charged oxygen atoms in the water molecules, which have a partial negative charge due to the unequal sharing of electrons in the covalent bonds between the hydrogen and oxygen atoms. The negatively charged chloride ions, chloride negative, are attracted to the positively charged hydrogen atoms in the water molecules, which have a partial positive charge. This attraction between the ions and water molecules is known as hydration or solvation, and it is responsible for the dissolution of the ionic compound in water. The solvated ions are surrounded by water molecules, forming a hydrated ion shell, which keeps them in solution and prevents them from reforming into the solid crystal. Naming compounds. For ionic compounds, the name of the cation, the positively charged ion, is listed first, followed by the name of the anion or the negatively charged ion with the suffix IDE added to the end. For example, the formula NaCl represents the ionic compound sodium chloride, with the name derived from the name of the sodium ion, sodium positive, and the name of the chloride ion, chlorine negative, with the IDE suffix added to the end. For covalent compounds, the name of the first element in the compound is listed first, followed by the name of the second element with the suffix IDE added to the end. Prefixes are also used to indicate the number of atoms of each element in the molecule. For example, the formula CO2 represents the covalent compound carbon dioxide, with the name derived from the name of the first element, carbon, first, followed by the name of the second element, oxygen, with the IDE suffix added to the end, and the prefix Di to indicate there are two oxygen atoms in the molecule. Suffixes play a crucial role in naming compounds as they help to indicate the type of compound and the elements or radicals present in it. For example, in magnesium sulfate, MgSO4, and magnesium sulfite, MgSO3, the suffixes ATE and ITE are used to distinguish the two compounds. In this case, the ATE suffix indicates that the compound is a sulfate, while the ITE suffix indicates that the compound is a sulfite. The difference between sulfate and sulfite is the number of oxygen atoms present in the anion. Sulfate, SO4, has 4 oxygen atoms, while sulfite, SO3, has 3 oxygen atoms. Thus, the suffixes ATE and ITE are used to differentiate between these two types of anions. So the name for N2O3 would be dinitrogen trioxide, and the name for HNO3 is nitric acid.